Hello, everybody. Welcome back for this week's Hubble Hangout. My name is Tony Darnell, and I think we got another great hangout planned for you this week. We're going to be talking about data and analyzing the universe. And so we've got all kinds of new stuff to show you, some new data sets that are available not only just for astronomers and people doing research, but also to the general public. And so we're going to show you some of these tools. We're going to talk about some of the data and some of the things you can learn from them and how you can access them as well. But before I get into all of that, I have to introduce, I don't have to, but I guess I should.
Excuse me?
Introduce my co-host, Dr. Carol Christian. She is the HST Outreach Project Scientist. See, I can read. I'm reading your little lower third there.
Hello.
I'm so proud of you.
Hello, everybody.
I have new skills. I've just got mad skills. And also joining me is Scott Lewis, the online outreach, what's that word? Specialist.
I'm just special. Just put special, and I'm good.
Scott Lewis.
Yeah. Yeah, you know, Scott, our little meme of Mo Bigger, Mo Better didn't catch on last week. Do you know that? At least I didn't see it.
Well, I'll work on that.
Yeah, Mo Bigger, Mo Bigger. Well, today we're talking about Mo Better. We are Mo Better today because we are going to be talking about some data that are coming from the Hubble Space Telescope and is being archived on the Mikulski Archive for Space Telescopes. Now, one of the things that you may not realize about what the Institute does, in addition to operating the Hubble on a day-to-day basis, it employs great many astronomers who do science with it also on a daily basis. But we also handle and distribute and serve the data that comes off of not just Hubble, but a lot of different instruments. And we're going to talk about that today with some of the people who are working on it. And joining me today is Dr. Molly Peoples, Astronom Molly.
Hi.
and she's going to tell us about it. She's been in Hangouts before. Welcome back, Molly. It's good to see you again.
It's good to be here. Also,
to explain the archive with us is Dr. Jason Tomlinson. He's been on these before. He is not on Twitter as he has in his lower third. Everybody says I'm getting a lot of
tweet for me.
Yeah. So welcome, Jason. Good.
I thought they said no ton Twitter. Okay, I get it.
No ton. Not on Twitter. Yes, and so everybody says you're getting a lot of glare from my glasses, so I should probably back up. I'll do this then. Okay. So there we go. Sorry, I can't.
It's still there. Yeah.
That's still there.
I'll do.
Yeah, that's good.
Yeah, there it's gone. Now, how about I can look up like this too?
Yeah, that's good.
So can we do spectroscopy on what's being reflected?
Yeah,
that's right. You can watch me surf the internet while I'm doing the hangout. I guess I better keep it clean, huh? Okay, so we want you guys to interact with us and ask us questions and talk to us about these the data that we're going to be showing you, as well as any questions you might have regarding Hubble or some of the science that can be done with this data that we're going to be showing you. But before we do, we should tell you how to do it. Now, there's a hint right there on my lower third. I am on Twitter, but I'm also looking for that, and I'm going to have Scott tell you how to do it. Scott,
that's right. I mean, it kind of helps if we show you how we can do that. So the best way, since you're watching us live right now, hopefully, if you're not, we'll give you those other things later. But as I'm seeing here, we have a bunch of people in our live chat. So we're up on YouTube right now, using a YouTube live event, and so I'm seeing a bunch of people already commenting. So hello, everyone in the YouTube live chat.
Hello.
And as Tony had mentioned, we are on Twitter, so we'll be live tweeting this event, and as far as any pictures and links that are going on with it, and we'll be using the hashtag Hubble Hangout. So if you have any questions or comments about spectroscopy and the topics that we'll be hitting today, please use that hashtag Hubble Hangout. And I'm also monitoring the comments that are being put up on our Facebook and Google Plus events. So if you have anything like that, I will try to get to them, but the best and most efficient way is the YouTube live chat and on Twitter.
Okay, so someone just joined. Who is this, John?
Yeah, this is John.
Okay, hi, John. You want to introduce yourself?
Yeah, I'm John O'Mara from St. Michael's College in the great state of Vermont, frequent Hubble user.
Oh, cool. All right, so you're here to tell us about the Spectral Archive as well.
Sure.
Awesome, great. Well, we're getting started just now, so welcome. We would like to have you have a lower third, but we don't have time to get into that right now, so we'll just go ahead and get started. So, as I mentioned at the start of this, we are talking about the Hubble Spectral Archive. Now, in the past we've given you hangouts on the Hubble Legacy Archive, which has to do with the older data that Hubble's been around for 25 years, folks. So we got a lot of data to serve, and from all kinds of different instruments. There's also the Mass Archive in general, which hosts not just data from Hubble, but Carol, can you give us a brief background? What are some of the other instruments that we're serving data from in the archive?
Oh my God! Well,
there's a lot, right? I mean, there's not. Well, you know.
Yes, all the Hubble.
There's Hubble.
And then, and people are most familiar with the imagery from the old cameras. You know, we have all the imagery from the old cameras that were removed, like WIPIC and WIPIC 2 and things like that. We had wide field camera 3, advanced camera for surveys, etc. And then the spectrographs, the STIS and COS, as they're called. But we have something like 13 missions in the archive, and the great thing is that with those data, now you don't have to select each mission and look for your favorite object. You can go to something called the portal, and you enter the name or the coordinates of the object, and it will go out, and depending on what you have specified, if you specify nothing, it searches for everything. If you specify like Hubble or Spitzer or Chandra or other archives, it will tell you what data it has. And then if you want that data to analyze, you can get it and download it and use your favorite reduction technique. The idea with the spectra is, well, imagery, it's true for imagery too, is that one of the ideas of the Hubble Legacy Archive was that you don't want to just, astronomers are tired of downloading all of the raw data before they can even see what they're going to get. So the idea of the Hubble Legacy Archive was to process the data, calibrate it, so an astronomer can take the data and say, wow, that's what I have, yes, that's what I want, now I'm going to do some analysis on it. So the Spectral Archive, we haven't had that, and so the idea, it's a lot of work to put it together, and you have to be careful that the calibration is right, and collect as much of the spectra as possible, and now people will be able to, you know, get the spectra. So we're going to learn all about that, because astronomers, A, they would like to look at the data as it's processed, and B, some of us are lazy and we just like to have the observatory do that calibration for us and at least get a first hint of the kind of astrophysics that we can do with it. So it's pretty cool.
That's right. It's not just laziness, it's also, you know,
on my part, I said like me.
Well, it's also, you know, 10 years from now, 15 years from now, when these instruments, heaven forbid, are no longer active, we want the data to still be useful, and they will still be useful. But as the expertise moves on to other things, and the people who are actively maintaining the calibration and integrity of the instruments are not doing that anymore, we want to leave behind a strong legacy of data for future generations of people to still be able to use and discover new things from.
Okay, so let's go ahead and get to this particular archive then. Now, over the years, this interface has undergone quite a few changes. It's gotten a lot easier to use for scientists. Oh, look, I'm going to do this now, so people don't have to deal with that. It's gotten a lot more easier to use over the years. But Jason, can you give us some background on what the what we're talking about today, the Spectral Archive itself? Give us some background on why it's just been set up, and have the data always been there and it's just recently become available through this?
Yeah.
Or give us some background on this.
Yeah, so it's funny you say that the interface has changed a lot over the years. You know, I like to think I'm still pre-mid-career, so I'm not that old, but I remember when you used to get your Hubble.
Your hair's a lot less grayer than mine. In fact, I don't see any.
I'm just going to keep my hand right here. I remember the days back in the 90s when we were working with the instrument called the faint object spectrograph. That was the first generation instrument on Hubble. And you would get your data mailed to you on these little magnetic tapes that were about as big as a playing card, sort of like maybe as big as a business card. And you would put that in your machine, and you would issue lots of obscure commands to read your data off.
Were they DLT tapes or DLTs?
Exabyte was what I had.
Exabyte. Oh, God.
Exabyte. And we had to carry the stacks of them through the snow.
I remember.
Okay.
It's better
To analyze them.
It's better than punch cards and floppy disks. Okay, I'm just. Oh, mag tape. Remember the mag tapes?
I remember those. Jason's too young. I remember.
The worst part was that when you put the tape into your machine, you then had to shovel more coal into the machine to read the tape.
I know. And pray it it was based on videotape technology, so it was amazing this stuff ran at all. Yeah. And you're always like, oh God, I hope I can read this data back off again. Yeah, I remember those days.
Huge. It was a huge deal when you started being able to get your data from Hubble over the internet, because then you could get it within a matter of weeks instead of months. And it's now down to the point, because the archive has continuously improved its technology, it's now down to the point where you can get your data sometimes within hours of the telescope taking your data. My personal record, a program I did a few years ago with Hubble, the data made it from the instrument costs to the computers on the observatory, down through the TDRS satellites that NASA operates to communicate with the satellite in orbit, through White Sands Missile Range, through Goddard Space Flight Center, and here to the Institute in 2.5 hours. So, 2.5 hours from the data being taken by Hubble, we had it on my postdoc's laptop, and we were dancing a little, jig.
And when was the paper written?
About 1.5 years later.
Oh, so that little, okay, so that made a big difference.
Actually a short period of time, to be fair.
Yeah.
Well, we've talked about data quite a bit here on these Hangouts, where the Hubble data, the process for getting it, and the fact that because Hubble is run by NASA and it's a taxpayer-funded program, everybody ultimately gets access to the data. But the scientists, the ones who, and Carol has told us about this before with the time allocation committee and things like that, where when you get time on Hubble, and you take your data, you're given usually the first shot at that data. It's something called, what do we call it? Embargo, I guess. Proprietary period. For usually it lasts about 1 year unless something special is arranged, or unless it's done with Hubble directed discretionary time, in which case the data become available to the public right away for everybody. And so Molly, this stuff here, this spectral data that we've got, does it fall under the same kind of umbrella as the other visual data? I mean, is there a proprietary period? Does it take? So is there a delay between when it's taken and when it's available?
The data that we're talking about today are the actual data is the exact same data that if you went into the MASS portal that Carol was describing and searched for what is publicly available data that COS has looked at in the far ultraviolet, and you just downloaded all of that, which is what we did a few weeks ago when preparing the final release. That's the data that we're talking about today. But the extra value that we've given to that is when the data are taken, they're taken in lots of different exposures that in order to actually do science on, you want to add up the different exposures to get a deeper, higher signal-to-noise spectrum. The same way that with images, you take a bunch of images and then you combine them to get a higher resolution, deeper image. And that combining of images has been available in the archive for users for decades, but has not yet been available at the level we are delivering in this archive now for Spectra.
Yeah, I would say the analogy I would use is that, imagine you're going to do research on a paper you're writing. Most people wrote term papers when they were in college. And let's say you're going to do research and you went to the library and the librarian handed you a stack of pages instead of a book. And you had to figure out what order the pages should be in before you could even get started on your research. That's kind of where we've been with our spectroscopy for years and years. We gave people the individual exposures, but we weren't putting them together into that fully combined way that would allow them to do their science from day one.
Scott, could you pull up that flowchart?
Well, hang on, just a sec. So while you are looking at the data, or you're going through the data in this sort of difficult format you were talking about, Jason, doing the science on it has been somewhat difficult. Now, most people who use Hubble data like to use the images. Most Hubble huggers that I know of in the general public, we care about the images. But Molly was just mentioning before we started that real science is done with the spectra. So let's go ahead and start, and then we'll put up the flow chart that Molly's talking about. But I want to take a look at the archive. So Scott, if you'll put that up. Let's take a look at what we're talking about here. This is available. There it is. So this is based off of the Mikulski Archive for Space Telescopes, MAST, and So tell us a little bit about what we're looking at here, Molly.
Well, right now what's flipping through are just some images of what you get if you click through the individual portal, which we'll do in a bit. If you wanted to go back to this question of what is the science that you're able to do with spectra that you just simply aren't able to get with regular images, the traditional way, I mean, so one way to think of it is these images keep flipping through, is you see all these squiggly lines on here? Mm-hmm. That's not noise, that's where the information is. So in these where you see these bright emission lines, the light's going up a lot, or these absorption lines where you see little divots in the light, or like, you know, this one that's this big comb of lines, or this one, those correspond to individual elements have different quantum signatures that respond to light differently. And as it turns out, most of the gas in the universe is at temperatures and densities such that the wavelengths of light that it most interacts with are in the ultraviolet. And so you have to go to space in order to see this light, which is why this Hubble Spectroscopic Archive is so powerful. And the location of each of these lines and the patterns tell you about the physical conditions of what's causing either this emission or absorption, which can really get at what is the physics of this star, or this diffuse gas around this galaxy, or the atmosphere of this planet that's passing in front of a star.
So I wanted to interject that as people are looking at the spectra, when you see the big dips, that's where an element or a molecule has absorbed the light. So, for example, we see this in the sun as well. So you have the light that comes from the sun, and then in the outer atmosphere, there are elements that absorb. In other cases, the absorption might be done at the star, or it might be intervening material. Sometimes we use the parent star and the light that goes through the atmosphere of a planet if it happens to pass in front of it, and we can look at what molecule or chemical is absorbing. In other cases, in some of these things you're seeing, when you see these spikes that go up, that's when a particular chemical element is emitting. And then you can also determine not only that the chemical is there, but as Molly said, what's the temperature, what the conditions are that create an environment for the chemical. And so you don't look at just one chemical, you look at all of them so that you can, and that's why it's astrophysics, you're looking at the physical conditions in which cause either the absorption, the emission, or sometimes you get both in an object.
Right, and so as we've pointed out before with past data archive hangouts, the images that we see from Hubble usually come from things like Wide Field Camera 3, the WIFC-3. They also in the past have come through, over the 25 years Hubble has been up there, it has had a lot of different cameras that take really amazing pictures. We've all seen that. But as both Molly and Carol just pointed out, these are the kinds of data that you can get different information from. Remember last week when we told you about this most distant galaxy, and they were looking at it through different filters, and they could kind of get a sense, because of how bright it was in a filter, how far away that galaxy was. That's called a photometric redshift. It's nowhere near as accurate as what we're talking about here. By looking at that galaxy through getting its spectra, you can actually see the redshift. And Molly was alluding to the fact that this is where the meat and potatoes are, where the rubber hits the road. What other analogy can I hit? It's like this is.
We're going to make the same joke.
Yeah.
It's Jason's joke, so I'll let him.
A very wise man once said, an astronomer, spectroscopist, somebody who helped train me, said, a spectrum is worth 1,000 pictures.
A spectrum is worth 1,000 pictures. So there you go. And there's two instruments on Hubble right now from which this data are. Well, maybe there's more, Molly, and you guys can let me know. But this is the Cosmic Origin Spectrograph and the STIS spectrograph, which I don't remember what that stands for.
Space Telescope Imaging Spectrograph.
Right.
Oh, there you go. And these are both
basically everything, as it turns out. It has an imaging camera. It has a spectrograph. It has a coronagraph. It can make your coffee in the morning. It does basically everything.
Does it do back rubs? Because that would be okay. Well, that's great. Yeah. So, and as we've talked about, and as Carol and both Molly have said in this hangout, these are give you wavelengths that you have to get out into space to see the ultraviolet, and Hubble's the only one in town, the only game in town for this wavelength, right, guys?
Yeah. So, the interesting thing about this is that the reason we can't see these wavelengths from the ground is that the atmosphere, and particularly the ozone in the atmosphere, very efficiently blocks these wavelengths. These are the wavelengths in the ultraviolet that would give you a very, very bad suntan.
Right, so it's a good thing.
Right.
Yeah.
So I like to say you can either have UV astronomy from the ground, or you can have all life on Earth, but you can't have both.
Choose one. Choose wisely.
So, since we decided it was...
I don't know, UV astronomy.
Well, there's a few of us...
I already burst into flames when I'm outside as is, so if that happened to where it's not being absorbed by the atmosphere, I'm just...
Space and do your UV astronomy from the ground, but anyway. Yeah, so that's a chief reason why we had to move our observatories into space. It's not only the blurring of the atmosphere that makes the stars twinkle, it's the fact that there are some colors of light or some wavelengths of light you simply cannot see from the ground at all.
Oh my gosh, I think I'm going to have to read this. Scott just posted it in the chat room. So Michael Jobin, this is terrible, but Scott, you're the one responsible.
I love thunderstorms.
So. I think his comment is, I think Molly knows something about molecules. Let's put on.
It's like I'm in my dream.
Oh dear.
Okay, so
Never heard that before.
all right, so let's get some. Can we get some data here? Help us. I want to get some data from this thing. Scott's been showing this thing flashing at us. So help us get some data, Molly. Tell them what to do.
So the other unique thing that we've done about this, done with this archive, is the way that you normally would get data from the archive. So for example, if both Jason and I work on quasar absorption lines, and so if you wanted to get a sample of all of the quasars that Hubble has looked at, before this archive, the way you would do that is you would say, well, that Tomlinson guy sure looked at a bunch. You'd go search for Tomlinson in the archive and download all of his data. And then you'd be like, Markarian 509, that's a good quasar. Maybe somebody's looked at that one. And so you'd try to kind of hodgepodge things together that way. But one of the kind of breakthroughs we had when constructing this archive is, despite all of its power and high popularity on the observatory, COST has only been around since 2009, and there actually hasn't really been that much data taken with it. Only about 1,200 objects or so have been looked at with COST, which in terms of scientific potential is enormous, but in terms of data volume really isn't that much. It actually all the data we're about to show you fit onto one of these. Mm-hmm. So you can just put in your pocket and download what's on here and use.
I carry one around with me just for sentimental
just in case,
Yeah.
So you're saying spectral data doesn't take up as much room as an image would then?
Reduced data, it's one-dimensional instead of two-dimensional.
Just a row of numbers. Awesome. Okay.
Yeah, all the bits that came off the telescope is quite a bit because there's a two-dimensional.
Because that's two-dimensional.
It's actually, I think, if I pulled the whole thing, it would be 5 terabytes.
Yeah.
But when you use like the reduced data and then you combine it like
exactly.
we have, it works out. I think our whole file
18
is
gigabytes.
Like 18 gigs.
Yeah. Which,
wow.
Scott scrolls down. There's actually a link on here. You can just download the entire thing.
Want the ententire thing? It's only
just click right there. Don't do it. I
have the bandwidth, but I'm not going to do that.
So what we realized was that the 1,200-ish objects means that we could just go in and sort them into, well, which ones are galaxies, which ones are quasars, which ones are stars.
Yeah. Okay, so, I want to get to that in a minute, but now I want to get some data. So show us how to do it.
That's what we're doing. Yeah, so scroll down.
Let's go down.
So click on pre-sorted target tables. And that's what this is. So at the top we have all of the data, which you can download from up there. And then we have things sorted by, what's in the solar system, what are galaxies and clusters, what kind, what's your favorite kind of star.
Oh, so wait a minute. I don't have to query this thing at all then. You've got it already sorted out.
We've already sorted things. So if you just want to download all of the, every extrasolar planet that's been looked at with COST that we could identify, or scroll down.
Yeah, Scott, if you click the targets link there.
Yeah, so actually, go to, that's a good one, I think.
That N-14 means what? That there's only 14?
That's how many targets. 14 targets. And so now you can get an idea of, well, what data exists. We have the names, we have the location on the sky, how many individual exposures, the target description that the person who asked for the data gave it, the alternative name, which is often the official name in either the NED, which is the kind of official extragalactic database of objects, or SIMBAD, which is the same thing for stars. The link to the MAST portal, which is what you would normally get for one of these if you just click on one. This is normally if you would search for this target in MAST, and this is what Carol was talking about earlier. This is what shows up. You get all of the images and spectra of this target that have been taken with different observatories. So, for example, SWIFT has looked at this one. You can see over there on the left that Galax has looked at it. So now if you click the back button,
well,
we have
Okay, hang on. You're going really fast here. So what I want to stay here for a sec. So
Okay.
I've got this. I'm looking at a lot of stuff on the left column. I'm seeing a bunch.
This is the MAST portal that Carol was talking about earlier. Normally, if you have a target that you have a name or a location on the sky, and you search and you want to know, well, what data exists on this target, this is what you get. You get, here are all the images, here are all the spectra, here are different missions that have looked at it, different instruments. On the right is an overlay of where on the sky the different footprints are. So the big squares are going to be your images, and then those little circles down right at where the star is, that's COST. That's the COST aperture.
Yeah.
Okay, so that's the spectrum there. So I can see that with this, there's 3 different missions that have seen it, HST, Galax, and SWIFT, and there's lots of instruments that have seen it. That's the ones below. And then in the middle column, these are the actual observations with a thumbnail, when available, of what it is we're looking at. And of course, there's the entire footprint off to the side. There's some squiggly lines right there. So this is this data right here. Now, John, let me get you into this just a little bit, John. Oh no! I just looked at your handle. Are you really Astronomira? Well, I need to get
the best.
I need to get an M name now and call myself Astrona Darnell. I feel Astronomali, Astronomira.
It's easy.
Astronotony.
I have to give credit where credit's due. I stole that idea from Molly. So.
Oh, did you? Oh, okay. All right then.
He's after the best.
Very creative. Astronotony. All right. So you use this stuff. You're a user of this data. Is this how you do it? Is this how you get it?
Well, I think traditionally how I would have done it in the past is to go through directly through MAST after going after one target in mind or one specific observation in mind. But the really nice thing about having it packaged up the way that they have now in the new archive is that it really facilitates discovery places for people who don't have really good spectral kung fu and how to manipulate the data. Because when you take any individual frame and you're trying to get something out of it, you may not completely understand what you're looking at 100%. Whereas if you have an archive which has gone and taken all the exposures of something and put them together for you, you can immediately start doing science with it.
So you either know astronomy, yes, astronomy, no, but no astronomy, guess so. You get squished like grape, right? See that you did it. You started with the spectral kung fu. I had to bring Mr. Miyagi into it. So.
There you go. There you go. Well, so, and I think what's exciting about archives like this, especially sort of refined data product archives like this, is that it's going to open up a lot more people to doing what's called archival proposals. That's another type of proposals that happen with Space Telescope, and it's the way that I think that Hubble is really going to be a century telescope. It's going to be a telescope people are using data from for 100 years, and that you can really mine this archive without having to do a lot of the work that takes a lot of time in preparing the data to go from something like that thumbnail on the MAST portal that you have right now to something you can actually use to do science. And if you can spend more of your time trying to do the science with the data and not trying to finesse the data, that really opens up a lot of possibilities, and it opens up possibilities for people who may not always be, say, quasar absorption light people, but who are galaxy people, and they can just go straight to a specific question in data that's ready for them to use.
Yeah.
And I think, to your point, the fact that it's grouped, the fact that you may have a particular object that's a starburst galaxy or something like that, and if you go here and you find this spectra, then you can see the other objects like it, and you go, oh, I didn't realize that there was an observation of my other favorite, object called blah blah blah, and then you can look at that data as well. Yeah. So the topical groupings are really, really useful when you're trying to look at a class of object that you're interested in.
Exactly. And so, Scott, if you go back to like the samples page, let's go to one that has more data, one of the galaxy or quasar ones, or white dwarfs. If you go back.
The other tab, I think, does it.
So I'm looking at...
yeah, there we are.
Yeah, so just scroll down and pick one that has like a lot of objects in it.
All stars, for instance.
Yeah.
Our stars has a lot.
Fine. White dwarfs are nice. White dwarfs are nice because they're very bright in the UV, and so you have very high signal to noise.
Really nice.
So one of the nice things about this one is so for example, Carol was mentioning if you have your favorite target, if you scroll to the top and you know the name of the target you're looking for, you can type it into the little search bar. So for example, type WD. There are a lot of white dwarfs names that start with WD, and they're all just going to pop up here. WD0. Because it's also searching, yeah. So here are a bunch of ones that start like that. And so now if you click, you can also, all of these tables are also sortable. So if you click, so erase your search bar. This is just an example. So click on number of exposures. Yep. And click on it again so it's reverse sort. Yeah. So these first few ones are ones that we use to calibrate the instrument, which is why there's an insanely large number of exposures. But if you just click on one, like maybe the, what'll be a good one? The WD1654, I'm pointing at the screen as if you can tell where I'm pointing. Down near the bottom. Yeah, that one.
Your telepathy is pretty good. We're cross-country. We're getting it going.
Yeah. So this is just an example of if you want to then see what data exists for this object, the top gives these histograms, and my random example isn't very good, gives sort of the demographics of what configurations was the instrument in when the different data were taken. And then as you scroll down, the first thing that shows up is the full combination of all of the spectra, and it looks very nice. And then as you scroll down, what you can see are the individual exposures, which will look a little bit rattier. But then the idea is that once they were combined, there's a lot more signal there that can be used for science.
Yeah.
Okay. Well, so I got a comment here from the Nebulous Mistress, which brings up the next point I want to bring up, and I'm assuming it's a she. It says, "Man, I wish this database was online when I wrote my thesis."
Hey. So that's what we love to hear.
Let's talk about that a little bit. Are you hoping, and what about new astronomers coming up with these tools? Do you think in a better position to ask science questions of this data than you guys were? Because Jason said something earlier about you go to the library and get just a bunch of pages in a book, and you're expected to sort through them yourself. Now,
so I did my thesis in the very late '90s and the early aughts, and we had, maths in those days. You went and you basically got one object at a time. So in the library analogy, you checked out one book at a time, and you took it home, and you went and checked out another one. And remember, it was in the form where the book wasn't bound; it was just a set of pages, right? Because they didn't combine the exposures into a single spectrum for each target. So you got one pile of pages at a time. Now we're in a situation where we hope that the users can go to the library and just get the pile of books they want and go off and do their research. They're not having to wade through the card catalog and figure out. Anybody remember what a card catalog is?
Yeah.
They're not having to wade through the catalog and figure out. It's sort of like the old days.
If you don't watch Ghostbusters, the opening scene,
right?
Card
It's like you have to know the name.
You always manage to make me feel old in these things. Why do you always?
just because.
It's like
you are.
needed to know the name of every book before you went in.
Yeah.
And now you can go and you just say, give me all the books you have on ectoplasm, and there it is.
Okay, but to be fair, back in the day, there weren't that many books to look at. Okay,
But you still had
Well,
to
you were
know-
looking in cuneiform, to be
You
fair.
still had to know their names and know where to find them. And then once you did have the data, you had to spend all of your time reinventing the same data reduction techniques that everybody else was spending their time doing. And to be fair, you still can download, even from these portals,
Sure.
all of the individual exposures, and if what you really want to do is combine them in some way that's specific to you, that's not the choices that we did, you can still do that.
You can still
But
get the
for
bundle of
most
pages
science
if you want.
purposes, time is better spent actually doing science on the reduced data
Yeah.
rather than trying to figure out the data's phone number and how to dial it.
Okay, well, then
I
let
don't
me
know if
ask.
this library analogy still has legs, but I'm going to use it one more time. When you're a user of Hubble, like me or Molly or John, you might have created a few data sets, and you're interested in going to get your data sets out of the archive. That's like you go check out a book you wrote, right? But you also, when you write that paper or do your research project, you'd like to read the books that everybody else wrote on that topic. And the reason this is really, really enabling is that it makes it very, very easy for you to go and quickly grab your data plus every other kind of data, every other data set on that same kind of object that everybody else has created. So you get the force multiplier effect of having all of it in one place.
Well, that brings up the next question I wanted to ask both of you guys. That's a perfect point to make right this moment, Jason, because and this is for all of you, and Carol, you can even chime in if you'd like to. But in this day and age, you see a lot of papers being published, a lot of science being done on the data, and they're saying, from the data, I have asked this question and reached this conclusion. And it's important now, isn't it, in science, especially using these archives and using the data that is now we're calling big data, to be able to reproduce those results effectively. And so does an archive like this let you do that better? If I read a paper, let's say Jason puts out a paper using this data, and I want to say, well, I'm not sure he's right, let me try it myself and see if I can get the same answer. This helps it a lot more than, say, back in the day when you only had the card catalog, right?
So way back in the day, when these people were children, I was working on star clusters, and in particular globular clusters, and there was a discrepancy in a number of people were researching the chemistry of those clusters using spectra. And so, but in those days and age, you went and you got the spectra, and it was your data. And so we had a conference where everybody kumbaya agreed to exchange the data, so they had to format the data, and they sent tapes back and forth and all this stuff, and then everybody would analyze each other's data. Those days are over. You just go get the data and you analyze it, and you say, well, why did this person get this, and will my algorithm work the same way? So I get Jason Spectra and I use my model or whatever, and then I say, oh, this is how it's different. So this really changed, and you get those answers very quickly. And so it doesn't take like a year. You have to have another conference a year later. Oh, we all did. You know, it was painful. It was very painful.
I would say that data archives have really strengthened the overall ethic of reproducibility, which is an important part.
Absolutely.
Overall.
And comparability of how different people analyze information.
Yeah.
Okay, well, here,
Another factor which we shouldn't overlook is that these data are from missions that that the public paid for. So, you know, we need to make sure that whatever we're generating is accessible and intelligible and useful, because it really belongs, just like Hubble itself, the data belongs to all of us.
And one of the things about these different samples that we've put together that, you know, has been fascinating just for us going through, and I'm sure certain members of the public with certain dispositions would also find fascinating to go through, is, you know, I had never seen a UV spectrum of a supernova before, and now I can just go to the supernova sample and click through and be like, wow, what's going on there, and look at that, and you know, I have gotten a lot better because I've just been looking at where I don't work on white dwarfs. I can now kind of go through white dwarfs and be like, oh, you look really like you've just got hydrogen and helium. Oh, you look like you've got some metal line absorption. That's interesting. Like it's just, once you have the full database that you can go through instead of just individual objects, there's just a lot of fascinating stuff that you can just kind of pick up by eye.
Yeah.
Okay, now, but here's what worries me about this, and it's not just about this archive, but all archives where you're getting already analyzed or processed data in some way. Are we introducing biases, and how careful are we that everybody is starting with the right foundation to ask their questions? Because what worries me is if somebody gets a wrong processing step wrong, and everybody's paper is based on this down the road, how susceptible are we to that?
Yeah. That was a big concern of ours because we are all users of this kind of stuff ourselves, and we know how difficult it can be to perform those reduction steps to get the analysis right. We also know that different scientists who've been trained to do this kind of thing make different judgments. A lot of the steps you do come down to judgment calls about whether you're willing to do this or that step, which may be computationally intensive. You know, there's never a single unique answer for every step in the process. So you have to, when you're doing it for yourself, you have to make choices, and when you're doing it for everybody, like we did, you have to often you have to make those same choices. So we actually brought in a group of experts from outside the institute, outside Space Telescope, and some people from inside, and we all got together over a period of a few months. And these are some of the best people you could possibly get who ever done spectroscopy, including people who've been doing it, you know, for the entire lifetime of Hubble and even before that.
Entire lifetime of me.
And we got them together and we talked about how to make these choices, and we know we can't produce data sets that are going to be perfect for every purpose. It's just not possible. But we know we can we thought, and we turned out to be right, that we could produce data sets that would be, you know, 90% useful to 90% of the science cases by making the broadest possible set of choices. And as we go along, and one of the reasons we've kind of arranged things this way, we have an email address for people to send us feedback, we have a website, we're doing this Hangout. We want people to tell us what the data could do for them that it's not doing, and then over time, the Institute will continue to support this and it will evolve, and we're hoping to make it even more useful in that way. So, you know, Tony, you raised...
Okay, but wait a minute. That bothers me a little bit, Jason, only because how can I, if I call you and tell you, well, the data's, what you're not saying, I hope, is that, well, the data's not doing what it needs to be doing for me, I need you to change it. I mean, isn't it this is an objective thing? These are measurements that we're taking. I'm more concerned about getting...
Well, so to rephrase your question, if, you know, we get an email that's saying, oh, it looks like, you know, you've got some weird, you know, error properties happening when you're combining the edge of this one segment with the edge of this other segment, and let me show you this example case where something's clearly going weird. We're like, oh, okay, we need to look at that.
Yeah,
that didn't show up in our tests. Yeah. It, you know.
Okay. But at some point there is an objective.
Wait, let me finish. The question that I had kept asking when we were trying to decide, okay, are we ready to release this product? The question that I kept asking Jason and other people on the team is, you know, well, you know, we know that there are always ways to improve the data product, and the question was, well, you know, you're someone who does spectroscopy for a living. Would you use this, you know, would you use this data product to do your own science? And once the answer was, well, yeah.
That's when we knew we were done.
We're like, okay, we're done.
And I also want to point something out. There are other notable fields of science, not all, but there are some where the research is done behind closed doors and paid for by commercial companies, and you don't get to see the data. This is a completely open process. Yeah. You can look at the data reduction code, you can modify the data reduction code, you can start from ground zero and get every little bit that came down from the telescope. You can
it's a good point.
Just yourself.
And the
complete open process.
Yeah, so, it's open source there to where you can see every step that was taken. Not just, oh, you're just going to take it because this is what we're giving you.
And the way that we're delivering these data is the individual exposures that went into the final edition that we're delivering are delivered along with that co-edition. So you can look at the individual exposures and look at the final product and be like, yeah, okay, that makes sense. Or
good. That's where I was hoping to get to, because there is some check, there's some objective starting point.
And let me reassure you that although astronomers are not the dominant science in this country, we are filled with skeptics. And
you noted.
our colleagues are skeptics, and they will go through all this and reassure themselves that the data is correct. So it's not like astronomers are like, oh yay, Jason reduced my data for me, so I'll just use that. No, we're a community of skeptics.
We've been showing and demonstrating these data products to our colleagues and other astronomers since the AAS meeting, the American Astronomical Society meeting in January. And I've had a couple people tell me that based on what they've seen, it doesn't meet their very, very strict requirements for this or that reason. And I say, well, sorry, but we'll try to, we can try to incorporate that in the future. But I've had, 20 times as many people tell me, boy, you just saved me a year's worth of effort trolling the archive and adding all this stuff up.
Or,
I wish I had this when I was a grad student.
Or my favorite response is, oh, my grad students could be really upset.
Yeah. Right. You're doing this.
Yeah, I'm very impressed by the searchability of this data set and how you can look at a variety of different objects and things. You have made it, I think, is extremely easy to ask science questions of this data. Wout Vanderheide, hi Wout, it's good to see you again. Is asking, well, I shouldn't say, is the entire library accessible for non-U.S. citizens?
Absolutely.
Because I'd like to have NASA benefits tax-free.
Yep, just click on that download all the data link and wait for a little bit.
Yep.
So anybody in the world can get access to this.
Yes, and well, if you're either from Europe or Canada, it's not tax-free.
Right.
ESA and Canadian
you bring up a good point. Hubble is a collaboration with ESA
absolutely.
and Canada. That's right. Okay, well that's very good. And so I want to talk a little bit about, well, first of all, let me ask you, Molly and Jason, have you shown everything you wanted to see? Is there something left that we should be showing that we haven't yet?
We had a couple of interesting little science nuggets that we thought we'd mention because it shows
go ahead.
Things that people discover with with data sets like these.
So Scott, I guess pull up that main welcome page. Which one do you want to show first?
Well, there was some nice graphics on the black backgrounds that showed the.
I think.
So which set am I going off of?
Well, the one I sent you the last time, the black slides with the.
Oh yeah.
Pictures. I'll just run through those real quick just to show you what kinds of things we're talking about.
And while those are being brought up, we're talking about open data, and one of the things that can be done with archives. One of the things we're really hoping will happen with making this archive both publicly available and easily searchable is the real power is when people propose to take observations with Hubble, they have their science question that they want to ask of the data they're getting. But a lot of different science questions can be asked and answered with the same data. So what's really going to come out of this archival data is questions and answers that the people who originally proposed those observations never even thought to ask in the first place. That if the data were just sitting in some drawer somewhere.
That's right.
Okay.
So Scott brought up a nice graphic. I wanted to just show a couple of things which are the sort of some science highlights for what you can get out of this stuff. One of the things that people can do with Hubble, this is actually with the this particular observation is with the STIS instrument, not COS, but it's the same idea. There's this planet, which is a Neptune-like planet, an ice giant orbiting a star called GJ436. And the planet is so close to its star that the radiation from the star is actually evaporating the atmosphere of the planet, boiling it away. And over time, hundreds of millions or maybe billions of years, the planet's just going to completely dissipate, and you might be left with just the rocky core. And if you take a spectrum of that planet, you can actually see the signature of the hydrogen and the oxygen boiling off the atmosphere of the planet with Hubble data. So that, the fact that there are planets being destroyed by their host stars was a real discovery of Hubble's, and this was the observation that did it.
And that you wouldn't have noticed any other way, would you? Really?
No, absolutely not. You could take pictures. You could take pictures of that that planet and that star all day, and you would never see this because number one, the planet's too close to the star to actually separate them, and number two is you wouldn't be able to see the fact that the gases coming off the planet have a velocity as they come off the planet, as they boil off. You can only measure those velocities and the content of that stuff that's boiling off with a spectrum in the ultraviolet. So
Okay.
it's a cool observation. And then if you go to the next slide in that set, this one is really cool, and I got to issue a disclaimer that I'm actually on the paper.
Andrew had a Hubble hangout about it
Yeah.
recently.
So it's our friend Andrew Fox who did
Right.
describe.
Yeah. So Andy Fox is an astronomer here at Space Telescope, and actually he was involved with the group of us that put this archive together. In addition to leading up this area of science, so there's these things called the Fermi bubbles. These are very high energetic. They're observed in gamma rays. These bubbles that come up out of the Milky Way galaxy, and it's thought that these were created by ejecta from the supermassive black hole that lives in the center of the Milky Way. So what Andy did was to take the gamma ray maps that was produced by NASA's Fermi satellite, and then use Hubble's COS instrument, the spectrograph, to look for the gas that's associated with this gamma ray emission. What we didn't know was whether whatever event it was from the supermassive black hole only generated this gamma ray emission, or whether it would actually driven, a bubble of gas up out of the disk and into this bubble shape. And when you observe objects on the other side of the bubble from where the sun is, you can actually see that gas flow. And in the same way as I mentioned for the exoplanet just now, you can only measure the gas velocities with the technique that Andy used. So the data that was used to produce these measurements, and that some of the data you're seeing in these little squiggly lines here in this graphic, are in our spectroscopic legacy archive. Andy's data and a bunch of data like it are sitting right there, and you can go and get it.
It's also decidedly American.
Well, yeah, that's
I'm going to say it's French.
Or French. Yes, it could be
it's
French.
kind of accidental. Yeah, so the joke there, you say it's French or American, Andy's English, but
Sorry, I don't see a Union Jack there.
yeah, the reason is that on the side facing us, the side facing the sun, which is the right side here in the graphic, that absorption is blue shifted. It's moving towards us, and the Doppler effect causes it, as it's moving toward us, to move to slightly shorter wavelengths. And then on the other side, where the gas is moving away, it's sort of in this flow which is moving like that up out of the center. On the other side, it's red shifted because the velocity is moving it away from us, and its wavelength gets a little longer. So in the spectral trace down there, the red stuff corresponds with the red stuff, and the blue stuff with the blue stuff.
And again, that velocity, those kinematics, you would never know if you didn't have a spectrum. If you just took a picture.
Okay. Did you have it? Yeah. So that shows the value of some of the things you're getting out of here. Did you have another use case there, Jason?
I don't.
Okay. So, well, good. I just want to make sure you got to show the ones you were thinking of, because I'd like to get you guys to comment on something that I've been thinking about quite a bit with these archives, and that is these. For a long time, we thought that, and I know that this isn't exactly big data because you can get the whole thing to fit on a thumb drive, and that's not exactly big data, but this idea that the data are becoming presentable in ways that are very interesting to not just scientists, but in ways that we probably might not have thought to look at these data before. I'd like to get you guys to comment a little bit about the importance of. There was a movement in the past, I don't even know what happened to it, of having something called a virtual observatory where lots of different data archives plugged into it, and you could ask science questions of the virtual observatory. I think those have kind of gone away a little bit in favor of these individual ones. But do you think this is the future? You don't even know what I was going to ask.
I don't agree with you, but go ahead.
About what? What did I say?
Already shot down.
What you just said.
Nope.
I don't agree with your premise, but go ahead.
I didn't start my premise yet. My premise.
No, observatories went away. It's not true, but go ahead.
All right. Well, I'm thinking of the ones that I knew of. Even if they don't go away, then how important do you think, and I'd like to get your comments and thoughts on this, these archives are to answering not just the science questions you know about, that you set out to answer, but maybe even think about those things you hadn't thought to answer. Do these visualization tools, you think, have a bright, how important do you think they're going to be to future scientists going forward? And maybe Molly, you could start commenting, and I'll just go down the row.
I I'm not going to dive into the whole virtual observatory.
Okay, I don't want to get bogged into that. What I meant to say was...
I'll argue with him later.
Yes.
What I will say
Next
is...
on Periscope, Carol berates Tony on this information.
I think you're going to start seeing a lot more of this idea of being able to search by what kinds of targets you're interested in, rather than just searching by the traditional way would be to search by a location on the sky. And if you're interested in physics, in what's going on with something physically, then, you know, you don't really care where it is on the sky, right? Even in the case of, you know, this mapping that flows out of the Milky Way, where you know, really do care to figure out that geometry, the location of those individual objects you're looking at on the sky to map the geometry, the first thing you care about is what those objects are, and then you care about where they are on the sky. The first thing is, well, is this object going to be able to be useful to answer my science question? So I think that mode of interacting with data is going to become a lot more common. And definitely I think that these kinds of archives, especially ones that give you data that you can use out of the box instead of having to just download and re-reduce all of the data in some painstaking way, is definitely going to increase the longevity of things.
Okay, John, how about you?
John O'Meara could talk about this better.
Yeah, I wanted to get to John on this. So let's get your thoughts on this.
I have two thoughts. I mean, one of them is that the other really exciting thing about this, and why it's exciting for me, because I mix ground and space-based astronomy all the time, is that I've worked on a similar effort with the Keck telescope in what we call the Kodiak survey, to build up a giant public survey.
Kodiak with a Q.
With a K. Yeah, but spell the Q at the end, right? And it's a
well.
But the purpose of that is to bring as much Keck data to public as well. But what's going to be really exciting is where these two things overlap, in the sense that there is going to be a significant parameter space from the Hubble spectroscopic archives and the ground-based spectroscopic archives, where, as long as, you know, and in many ways Kodiak's searchability was inspired by MAST and then archives like this, to try to give as much discovery space to people who haven't thought explicitly about the nitty-gritty details of data reduction and this, that, and the other thing. And so I'm really excited about seeing how these things might overlap. And the other point that I was going to make real quickly is that, and not to sound like a downer, but we're not going to have a UV spectrograph in space forever. And the great opportunities afforded by archives which have given a lot of thought to things like this is going to be really helpful continuing our ability to do UV space astronomy.
That's true. We brought that point up in many hangouts where Hubble's the only game in town.
And I think graduate students will be trained on archives like this, because they won't have new data to take like this for at least for a while.
Good point. For educational use as well, this will be an amazing resource for people. Jason, can I get your thoughts on that?
Well, yeah, it's funny. So a couple things. The Kodiak project is a perfect example of the power of unleashing data and unlocking it, taking it out of the individual astronomer's desk drawer and putting it in the public domain. The Keck project, the Keck telescope in Hawaii, organized by private universities, they never were obliged by the law to release their data until NASA made them do it. Now you're starting to see more and more of the Keck data come out in public, and people are using it. You're seeing the publication rates and the impact of that data finally come out. The other thing is a story I heard recently. You know, we all know that back in the medieval times, the reason all the Greek and Roman manuscripts survived was that the monks were copying them, right?
Well, I don't have first-hand experience, but
do you know why they had to copy them? It wasn't that they wanted to read more copies. It was that the copies sitting on the shelf had a finite lifetime, because literally the bookworms would eat them. So even if you didn't want to disseminate the manuscript and pass the information around, you still had to make sure that it stayed alive by copying the version that you had in your monastery, because otherwise it would get eaten by the worms. So what we're in that same way, what we're doing here is keeping a database alive. We're making sure, you know, through our own intellects and through the work of our IT people and the whole process, making sure that that data stays alive and available. You know, you're not going to be able to read a CD in 15 years. Already, my kids who are 4 and 8, they don't know what a vinyl record is.
Oh yeah, well we've all so anybody who's had a floppy disk and had to make it go get it.
So you can't
We can make them hipsters, and then they will know.
How long are these going to be useful?
Right, you can't rely on the physical medium. So we're, you know, it's our job here at Space Telescope to make sure that the data itself, is the thing we're trying to preserve, stays in the form that's usable through the decades. Eventually, as O'Mara says, Hubble isn't going to last forever, but eventually we're going to have a telescope that's much bigger. A lot of us are working on a 10 or 12 meter space telescope that will follow JWST, and we will definitely, absolutely want to reobserve some of the stuff that Hubble's looked at, and we'll want to go back and compare new results with those future observatories to what Hubble saw 20, 30 years before. We have to have these archives in place, and they have to still be intelligible, readable to us for that to work. So there's a really strong reason why we're keeping these things away from the bookworms.
Right.
If I could go back on just that last point for 2 seconds.
Real fast, because we're running
with the remaining years of Hubble that we have, every second is precious. And so the other thing that this archive does is it helps inform the last set of proposals that will be made on Hubble, A, so that we're not wasting time, and B, so that we really are getting the best photons down the bucket. Yeah. And archives like this are crucial for things like that.
Yes, and you guys are raising a lot of really interesting topics that I like to get into, not just the educational aspects of what these archives can bring, but also the fact that what Jason brought up, the perpetuating of the data set, the saving of them to make sure we don't lose any of this stuff, as well as making, as John points out, more efficient use of the tools that we do have already, and we don't duplicate efforts. So these are all excellent points. And big data, oh my gosh, that's like 10 hangouts, all right there. So we could really go into a lot of this stuff. But I hope you guys got a good introduction into this new Spectral Archive that's out, available on mass now. I want to thank Molly Peoples, Jason Tumlinson, and John O'Meara for telling us a little bit about it. Go visit, go ask it questions, go explore. It's there for you. It's wide open and ready to go, and I am excited for this. Hopefully we'll see a lot of really cool new science coming out of it. And I even wanted to talk about citizen science impact, but we just didn't have time. So anyway,
somebody turn it all into an art project, you know? With like,
yeah.
Exactly. There's a lot of amazing things.
Oh, we're doing that. Okay.
Okay, guys. Well, thank you all for. I guess we'll have to stop it there. I did see one quick comment from Twitter from DaysOff77, who's talking about a great library from HST. What a great tool, the Hubble Legacy Offside Archive. Please, guys, go explore. This is your data set, so we hope you guys can get a lot of good use out of it. The astronomers, I'm sure, will, and we'll look forward to see what comes out of it. On behalf of Carol Christian and Scott Lewis, I want to thank you all for watching, and as always,
keep looking up.
Looking up.
Hello, everybody. Welcome back for this week's Hubble Hangout. My name is Tony Darnell, and I think we got another great hangout planned for you this week. We're going to be talking about data and analyzing the universe. And so we've got all kinds of new stuff to show you, some new data sets that are available not only just for astronomers and people doing research, but also to the general public. And so we're going to show you some of these tools. We're going to talk about some of the data and some of the things you can learn from them and how you can access them as well. But before I get into all of that, I have to introduce, I don't have to, but I guess I should.
Excuse me.
Introduce my co-host, Dr. Carol Christian. She is the HST Outreach Project Scientist. See, I can read. I'm reading your little lower third there.
Hello.
I'm so proud of you.
Hello, everybody.
I have new skills. I've just got mad skills. And also joining me is Scott Lewis, the online outreach, what's that word? Specialist.
I'm just special. Just put special, and I'm good.
Scott Lewis.
Yeah. Yeah, you know, Scott, our little meme of Mo Bigger, Mo Better didn't catch on last week. Do you know that? At least I didn't see it.
Well, I'll work on that.
Yeah, Mo Bigger, Mo Bigger. Well, today we're talking about Mo Better. We are Mo Better today because we are going to be talking about some data that are coming from the Hubble Space Telescope and is being archived on the Mikulski Archive for Space Telescopes. Now, one of the things that you may not realize about what the Institute does, in addition to operating the Hubble on a day-to-day basis. It employs great many astronomers who do science with it also on a daily basis. But we also handle and distribute and serve the data that comes off of not just Hubble, but a lot of different instruments. And we're going to talk about that today with some of the people who are working on it. And joining me today is Dr. Molly Peoples, Astronom Molly.
Hi.
and she's going to tell us about it. She's been in Hangouts before. Welcome back, Molly. It's good to see you again.
It's good to be here.
Also, to explain the archive with us is Dr. Jason Tomlinson. He's been on these before. He is not on Twitter as he has in his lower third. Everybody says I'm getting a lot of
tweet for me.
Yeah. So welcome, Jason. Good.
I thought they said no ton Twitter. Okay, I get it.
No ton. Not on Twitter. Yes, and so everybody says you're getting a lot of glare from my glasses, so I should probably back up. I'll do this then. Okay. So there we go. Sorry, I can't.
It's still there. Yeah.
That's still
I can't.
there.
I'll do.
Yeah, that's good.
There, it's gone. Now, how about I can look up like this too?
Yeah, that's good.
So can we do spectroscopy on what's being reflected?
Yeah,
That's right. You can watch me surf the internet while I'm doing the Hangout. Guess I better keep it clean, huh? Okay, so we want you guys to interact with us and ask us questions and talk to us about these the data that we're going to be showing you, as well as any questions you might have regarding Hubble or some of the science that can be done with this data that we're going to be showing you. But before we do, we should tell you how to do it. Now, there's a hint right there on my lower third. I am on Twitter, but I'm also looking for that.
One of the ideas of the Hubble Legacy Archive was that you don't want to just... Astronomers are tired of downloading all of the raw data before they can even see what they're going to get. So the idea of the Hubble Legacy Archive was to process the data, calibrate it, so an astronomer can take the data and say, wow, that's what I have, yes, that's what I want, now I'm going to do some analysis on it. So the Spectral Archive, we haven't had that, and so the idea, it's a lot of work to put it together, and you have to be careful that the calibration is right, and collect as much of the spectra as possible, and now people will be able to, get the spectra. So we're going to learn all about that, because astronomers, A, they would like to look at the data as it's processed, and B, some of us are lazy and we just like to have the observatory do that calibration for us and at least get a first hint of the kind of astrophysics that we can do with it. So it's pretty cool.
That's right.
It's not just laziness, it's also,
on my part, I said like me.
Well, it's also, 10 years from now, 15 years from now, when these instruments, heaven forbid, are no longer active, we want the data to still be useful, and they will still be useful. But as the expertise moves on to other things, and the people who are actively maintaining the calibration and integrity of the instruments are not doing that anymore, we want to leave behind a strong legacy of data for future generations of people to still be able to use and discover new things from.
Okay, so let's go ahead and get to this particular the MAST archive in general, which hosts not just data from Hubble, but Carol, can you give us a brief background? What are some of the other instruments that we're serving data from in the archive?
Oh my God! Well.
There's a lot, right? I mean, there's not. Well,
yes, all the Hubble. And then, and people are most familiar with the imagery from the old cameras. We have all the imagery from the old cameras that were removed, like WIPIC and WIPIC 2 and things like that. We had wide field camera 3, advanced camera for surveys, etc. And then the spectrographs, the STIS and COS, as they're called. But we have something like 13 missions in the archive, and the great thing is that with those data, now you don't have to select each mission and look for your favorite object. You can go to something called the portal, and you enter the name or the coordinates of the object, and it will go out, and depending on what you have specified, if you specify nothing, it searches for everything. If you specify like Hubble or Spitzer or Chandra or other archives, it will tell you what data it has. And then if you want that data to analyze, you can get it and download it and use your favorite reduction technique. The idea with the spectra is Well, imagery, it's true for imagery too, is that
And I'm going to have Scott tell you how to do it. Scott, can you
That's
do
right.
this?
I mean, it kind of helps if we show you how we can do that. So the best way, since you're watching us live right now, hopefully, if you're not, we'll give you those other things later. But as I'm seeing here, we have a bunch of people in our live chat. So we're up on YouTube right now using a YouTube live event. And so I'm seeing a bunch of people already commenting. So hello, everyone in the YouTube live chat.
Hello!
And as Tony had mentioned, we are on Twitter, so we'll be live tweeting this event and as far as any pictures and links that are going on with it, and we'll be using the hashtag Hubble Hangout. So if you have any questions or comments about spectroscopy and the topics that we'll be hitting today, please use that hashtag Hubble Hangout. And I'm also monitoring the comments that are being put up on our Facebook and Google Plus events. So if you have anything like that, I will try to get to them, but the best and most efficient way is the YouTube live chat and on Twitter.
Okay, so someone just joined. Who is this, John?
Yeah, this is John.
Okay, hi, John. You want to introduce yourself?
Yeah, I'm John O'Mara from St. Michael's College in the great state of Vermont, frequent Hubble user.
Oh, cool. All right, so you're here to tell us about the Spectral Archive as well.
Sure.
Awesome, great. Well, we're getting started just now, so welcome. We would like to have you have a lower third, but we don't have time to get into that right now, so we'll just go ahead and get started. So, as I mentioned at the start of this, we are talking about the Hubble Spectral Archive. Now, in the past we've given you hangouts on the Hubble Legacy Archive, which has to do with the older data that Hubble's been around for 25 years, folks. So we got a lot of data to serve, and from all kinds of different instruments. There's also